and create an item type. And basically this table is just going to describe just the quality item type. Down a bigger number of in. I have no idea. We're ID. But I'm going to foreign keys are going to be defined products. So I'm going to commit that are going to be representative of my individual products. So I'm going to come in and I'm going to call this product instead. And after that, let's just get rid of, well, I'll leave the primary key inside of there. So for my products, I'm going to have type ID, which is going to store either business, casual, or athletic inside of it. So I'm going to call that type ID, int, and it's going to be unsigned and not null. And where do I get that from? Well, this guy down here. This is product type, see, unsigned, and that's going to be primary key. Obviously, this isn't a primary key, however, but that's how I'm referencing that. This is going to be a foreign key, and I just need to type in type ID to reference that that is a foreign key, and then references product type and ID, which is the specific part of the product type table that we are referencing. Then my product, of course, is going to have a name, which is going to be a variable number of characters that I'm going to say is 30 in length, and it must have a value. What else am I going to have? Supplier. So this could be like, the name is going to be like the Speed Force, and the supplier is going to be Nike in this example. And I have no idea if Nike has a shoe called the Speed Force, but I think you get the point of that. Again, this is going to be not null for supplier. Then I can have a description that goes and explains what I'm working with. I need a blob, a bigger number of characters to describe the shoe. So I'm going to use the blob data type. And then I'm going to have a primary key just like I did before. And click the lightning bolt. No errors down here. And if I come over to tables and refresh, now you're going to see that I have a product. And you can see all the different data types that are stored there. So now let's create our other individual pieces. So I want to come in and create an item type. And basically this table is just going to describe just the quality of an item. So it's going to have a reference to the product ID, as well as the size, color, a picture, and a price. So that's all of those things. So let's just get rid of all this. And then I'll show you here in a second how these are all going to link together. So I'm going to link to product ID, int, unsigned, not null. And again, define that this is a foreign key that I am referencing, which is going to be product ID. This is referencing this right here. And then it's going to say specifically that it references the table, product, and the individual column ID in it. And then I'm going to list all the individual things that I want to store in here, like the size of the shoe, not null, color of shoe, that's going to be a variable number of characters, which is going to be 30 in length as a max. Again, not null. Picture, I'm not actually going to store a picture, but I'm going to store a URL that's going to link to a picture or a place on my machine, my server, where I'm going to be storing those pictures. So you don't store the actual picture, you store a link to it. Of course, we're going to need a price, and this is going to be a decimal as well. Well, actually, the picture should not be. This should be a variable number of characters. Let's copy this, throw that there. And then this is going to be a variable number of characters. And I'm going to make this really long. I'm going to say 256 in length, not null. And I could go and give it a default value, but whatever. I'll just keep it the way it is right there. Price, and I'm going to have that be not null. Okay, So you can see I'm breaking up the descriptions of all these individual tables into individual pieces. So this is going to be an item to specific information. Click that, tables, and refresh all. And now you can see that item is right here and all the data types that are defined for it. Now I'm going to create my sales orders. So come in here, get rid of all of this. And this table is only going to have information that's going to be pertaining to the order. And it's not going to contain information about products and prices and all those other different things. And basically what I'm doing with this sales order table is simulating two people agreeing to do business. So what am I going to want to store in that situation? I'm going to want to store the time of that event, a purchase order, and a means of payment. So I'm just thinking through the whole entire process. So I'm going to say sales order, and then what am I going to have? Well, I need to define the two people that are doing business. So we're going to have customer ID, integer. It's going to be unsigned, and we must have a value for it. What else am I going to have? Well, I'm agreeing that two people are doing business, so I'm also going to have a salesperson ID, which again is going to be an int, which is going to be unsigned and not null. And then I need to reference that these are foreign keys. So foreign key, and then say customer ID is going to be associated or is going to references the customer table and the ID inside of it. Then I'm going to do the same thing for my salesperson. So let's just copy this, paste it inside of there, and change this to salesperson ID. This is where that comes from, so I'm just going to copy it, paste it inside of there. And then it's going to reference the salesperson table. So let's just go and get this, paste that right there, and ID specifically in the salesperson table. So if you want to make sure this is what I'm referencing, that's going to be the foreign key. That's where it's coming from, and that's how I'm doing it. What else did I say? Well, remember, we're simulating two people agreeing to do business. Well, I'd like to also, in that situation, know when the order was taken. So time order taken. And this is a time. So what we're going to do is give it the timestamp data type, not null. We're going to want to track the purchase order number because a purchase order was written up and each purchase order has a number. So there we go. This is going to be an integer, and it's going to be not null again. Then we're going to have a credit card being handed over, so credit card number. I'm going to have this be a variable number of characters, 16 in length, not null. What else do we need to know about credit cards? Credit card expiration month. This is going to be a tiny int because of how small the number is. We're also going to have credit card expiration year, and this is also going to be a tiny int, not null. And then each credit card also has the secret code, so credit card secret code. Again, this is going to be a tiny int, not null. And then we're going to have name on card, variable number of characters, and let's say I want this to be 60. And again, not null. And then we have our primary key. All right. And if we typed, credit card, let's go in here and make sure we typed everything in right. Expiration month, credit card number, purchase order number, time order taken, and all of those individual pieces. And everything looks good. So let's go and run it, or create it, I mean. Down here, there's no problems. Come up here to tables, refresh all, and now we have our sales order as well. And you can see all that information right there if you want to pause your screen. If we do, of course, make an error, I will show you here in a minute how to go and fix and alter the tables. All right, so we have our sales orders. Now we want to have our sales items. Just want to review exactly how these are going to relate. We're going to have our individual product type. That is going to have an identification number, which is going to be referenced in the individual products. So this is going to be business, casual, or athletic. That is going to be referenced in the product table. Its ID for the products, which have the name, supplier, descriptions, are going to be referenced in the item table. So that's primary key is going to go to this foreign key right here. The items have the size, color, picture, and price. That ID is going to be referenced in the sales items, and then the sales items are going to be quantity, discount, taxable, and tax rate. That ID is going to be referenced in our sales orders. So that just means the only thing left is to go and put our sales item information in. And so that you didn't have to watch me type all that in again, I went and created it ahead of time, and this is the sales items. So basically, each item that is part of an order is going to go in its own table, and it's then going to be linked to the order with the sales order ID. And this is just going to simulate picking up a quantity of an individual item with a certain discount and a certain tax rate, and the item itself is hidden in the item table, and specifically 100% defined specifically there in a way that makes it easy to refer to it just with its ID. And the reason we're doing all this is if I were to go and list color, size, or anything else, that's going to break that ability to consider items in a self-contained way, which would be a bad thing, which is why we're breaking the tables up the way that we are. And whenever you are creating a database design, it's very important to consider that the data in the database be just that, data. It's often better to perform calculations outside of the database versus storing those calculations, such as total sales amounts and things like that, which I will show you here very soon how to do. So let's say now that we have all this created, well, first off, I have to go and actually create my sales item table and come over here and refresh, and there it is. So sales items, and now we have all of our individual different tables for our database setup. So let's talk about altering tables, because I said that we can alter tables. Let's come in here to, well, we don't need any of these, so yeah, don't save that. All right, so we're inside of here. How do you go about altering a table? So let's say that I want to add a new column. Well, what I would do is say alter table, and let's say that I want to add it to the sales items table. What I would do is, let's say I wanted to add the day of the week that this sales item was created or whatever. I could do add day of week and say that it's going to be a variable number of characters, 8 in length. I would then follow that up with a semicolon and go and create it. And if I did, let's come over to tables, refresh all, sales item, click on sales item, and you're going to see day of the week is right there. I could also come in and modify that column. So I'm going to again say alter table, sales item, modify. So instead of add, I'm going to say modify, day of the week. And let's say that I want it to be a variable number of characters that are 9 in length, and that I want to mark this as not null. Execute it. Again, you have to come in and refresh it. And if I go into sales item, you're now going to see that it's variable number of characters 9. Okay, so that's another way to alter. Another thing that I could do is, let's say that I would want to come in here and drop this column. Let's decide I don't like having weekday inside of there after all. Well, I could just go in, alter, table, sales, item, which is the table name, and drop column and weekday. And execute it. And now if we come in and refresh this, we're going to see that inside of sales item, we no longer have weekday. We do have day of the week. So let's go and get rid of day of the week. Execute that and refresh it again. Sales item, and now you see it's gone. All right. Well, what would happen if we would like to come in here and let's create another table? So let's create a table and let's call this transaction type. And let's do all kinds of funky things with it. So let's say we have a name, variable number of characters and 30 and not null. Let's say we have payment type, variable number of characters, and have this be 30 as well, not null. And then it's going to have a primary key and auto increment, and this will be the primary key. Close that off, and let's create that table. Refresh, transaction types right there. We could then come in and rename our table if we would like. So just go rename table. So credit card, and let's call this transaction, not number of characters, and have this be 30 as well, not null. And then it's going to have a primary key and auto increment, and this will be the primary key. Close that off, and let's create that table. Refresh, transaction types right there. We could then come in and rename our table if we would like. So just go rename table, transaction type to, let's say we want it to be called transaction instead. Execute, refresh, transaction type became transaction. We're also going to be able to create an index, and let's say we want to create an index based off of a single column. We can say create index transaction ID on transaction name, create that. We could also come in and create an index based off of two columns. So let's change this to transaction ID 2 on, and then say transaction name as well as payment type. Execute that, and we created another one. We'd also be able to come in here and delete data that is in a table just by saying truncate table transaction. There's nothing in it right now, but that doesn't matter. That'll work. And then finally, we could drop the table all together just by saying name to name, an index based off of a single column. We can say create index transaction ID on transaction name. Create that. We could also come in and create an index based off of two columns. So let's change this to transaction ID 2 on, and then say transaction name as well as payment type. Execute that, and we created another one. We'd also be able to come in here and delete data that is in a table just by saying truncate table transaction. There's nothing in it right now, but that doesn't matter. That'll work. And then finally, we could drop the table all together just by saying drop table transaction, and it's gone. You can see over here. All right, so there you go. There's a whole bunch of different ways in which we can alter columns and tables. And now I'm going to show you how to alter tables inside the workbench. Now you're also going to be able to a different thing. We'd also be able to come in as P2 on, and then say transaction name as well as payment type. Execute that, and we created another one. We'd also be able to come in here and delete data that is in a table just by saying truncate table. Transaction. So transaction. Okay, that'll work. And then finally, we could drop the table all together just by saying drop table transaction. And it's gone. You can see over here. All right. So there you go. There's a whole bunch of different ways in which we can alter columns and tables. And now I'm going to show you how to alter tables inside the workbench. Now you're also going to be able to view as well as alter tables just by coming over to your table and right-clicking on it and then coming down to where it says Alter Table. You can see then that it gives you all the information about your table. In this situation, it's our customer table. You can change the name just by clicking on it and then typing in a different name. You can change all of the different constraints as well as the data types. You can come in here and mark this as a primary key. This stands for not null. This means unique. This is binary. This is unsigned. This is zero fill, which means it pads the displayed field with zeros. This AI stands for auto increment. This is going to be generated, which means that it contains functions that auto create values. And then you can also put a default value inside of here. You're also going to be able to double click to add columns as well as right click to delete selected pieces of information. And of course, if you make any of these changes whenever you're done, come down here and click on apply to apply those changes. But we're not going to change anything right now. Instead, I'm going to show you how to both insert as well as update and delete database values. So let's click on our query tab once again. I'm going to first off go in here and insert some information into our product type table. To do so, you just go insert into whatever your name is for the table you want to insert into. This is going to be product type. You're then going to list the pieces of data you want to enter by their name. So I'm going to say I want to enter name and ID. Follow that up with values, and I'm going to put this on the next line so it's easier to fit everything. And then inside of parentheses, what you want to put in. So I'm going to say business, and then for the automatically generated primary key, you just put in null, and it automatically generates it for you. Whenever I do that, I can execute it, and then that piece of information will go inside of there. I'm then going to also put casual inside of there, and we'll look at the information here in a second. So I'm going to go casual, and again, click on that, and then athletic is going to be the last piece of data, and go and execute that. Now we would be able to come in here and go select and a star from and product left, and again, we'll put in, and for the automatically generated primary key, you just put in null, and it automatically generates it for you. Whenever I do that, I can execute it, and then that piece, and it automatically generates it for you. Whenever I do that, I can execute it, and then that piece of information will go inside of there. I'm then going to also put casual inside of there, and we'll look at the information here in a second. So I'm going to go casual, and again, click on that, and then athletic is going to be the last piece of data, and go and execute that. Now we would be able to come in here and go select and a star from and product type, and go click out of there, and we'll look at the information here in a second. So I'm going to go casual, and again, click on that, and then athletic is going to be the last piece of data, and go and execute that. Now we would be able to come in here and go select and a star from and product type is the name of our table, and execute that. Whoops, product type. I said product type and then typed in product ID. And whenever you do, you can see our pieces of data, which is casual, business, and athletic, and the IDs that we're auto created for us. Well, you can also input data in without listing over and over the column names as long as you put them in order. So let's just go out of this and go back to this part. So we can say insert into, and this time I'm going to put individual products inside of here. And then I'm going to put values like this. Let's bring values up here. And as long as I input them in the correct order, I don't need to go and list the column names. So I went and created this information ahead of time, pasted it in there. So now you're going to see if we have product here, here's product. So there's going to be the type, which is either going to be business, casual, or athletic. The name, the supplier, the description, and ID is auto-generated by putting in null. You can see I put product types, all the different product types, the individual name, as well as the supplier, a description, and then null at the very end. And then you're going to separate all those with, of course, parentheses around all the data, and then commas. And then at the very end, put a semicolon. And I have all of this available in the description. You can get all of this stuff. And we execute it. And then what we can do is do a select all on this and select everything from product like that and execute it. And you can see all those individual pieces of data that are inside of there and all of the auto-generated IDs. All right, so pretty cool stuff. Now I'm going to do the same thing for our customer information. And I actually auto-generated all this stuff using a Python script, which is also in the description if you want to go and get that, if you want to generate all these different pieces. Or like I said, I have all these commands inside of here. You can see right here, I'm going insert into customer, first name, last name, email, company, street, city, all of the information for all of our individual customers, all surrounded with parentheses with a comma at the end to separate all of the customer data, semicolon at the very end. Execute that. Then we can come in and go select everything from the customer table, execute it, and you can see all of our customer information is being stored in the database as well. All right, so neat stuff. Now I'm going to do the same thing for our salespeople. So once again, come in here, paste that inside of there. Here's insert into salesperson, all of the individual pieces, and at the very end, put a semicolon. Don't have as many salespeople, only have 5 of them. And we can come in here, boom, and then go and select everything from salesperson table, and that's all been properly inputted as well. One thing that I have noticed is with my sales order table, whenever I come in here and click on that, if I come down here with my purchase orders, the way I organized this was the purchase order numbers are going to be the year, month, day, as well as the time the purchase took place. Well, I actually need a bigger number than an integer inside of there for that. So what I want to do is come in and alter that table. So I'm going to say alter table, sales, order, and I want to modify the data type. So I'm going to say purchase, order, number, and I'm going to change it into a big integer that's going to be unsigned and not null. And I can put this on a separate line if I'd like. So purchase order number, which was an integer right here, I'm going to make it into a big int instead that's unsigned and not null. Execute that. You can see down here, response is where there would be an error message if there was an error, but there isn't. So we come in here and we can refresh this. And now you can see it's a big int and it's going to be able to hold my gigantic purchase order numbers. Had another error here also with my sales order in which I was trying to auto-generate the secret codes. So here's credit card secret code. Well, I knew that the secret code could be up to 999, but I didn't set it up that way because it's set up as a tiny int. I need that also to be altered. That's also in sales order. So I'm going to go sales order, modify, and then I'm going to say credit card secret code, and I'm going to change that into a small int. So let's change it into a small int. Unsigned, not null again, and we can go and execute that. And we can see if we come in here and refresh this, refresh all, whoops, let's come in sales order, and you can see that that's now a small int right there. Okay, so a couple little changes that we make as we create our database, totally normal. Now what I want to do is come in and insert my database, totally normal. Now what I want to do is changes that we make as we create our database, totally normal. Now what I want to do is come in and insert my individual items. And there all those are. So insert into items and the values. We click on item. You're going to see here size, color, picture, price, ID. And you can see right here all of those individual pieces of data. Again, surrounded with parentheses, separated with commas, and make sure that the very last one is a semicolon, which it is. And then we can execute that. And we'll see that item is also going to be set up properly. So you can also type in these commands like this. It's just kind of a can be a problem. So harder to read. Select from item like this, run it, and there's all those items. I can then come in and put in my sales orders. So there's all that information, whole bunch of information. And sales orders, of course, is going to be customer ID, salesperson ID, time order taken, purchase orders, all that information. That is all right here. Again, just make sure that I have a semicolon here at the very, very end. I do. And there it is. And we can go and execute that. And then we can copy the sales error here. That is all right. I do. And so there's, I can then come in and put in my sales orders. So there's all that information, whole bunch of information, and sales, all those items. It's like so going to be set up properly. So You can also type in these commands like this. It's just kind of a can be a problem. So harder to read. Select from item like this, run it, and there's all those items. I can then come in and put in my sales orders. So there's all that information, whole bunch of information. And sales orders, of course, is going to be customer ID, salesperson ID, time order taken, purchase orders, all that information. That is all right here. Again, just make sure that I have a semicolon here at the very, very end. I do. And there it is. And we can go and execute that. And then we can copy sales order and delete that and select everything from sales order. Okay, and whenever we put through those sales orders, we'll be able to see all of them here. Just a special note here, all of my IDs start at 201. Whenever this is created, I accidentally hit this twice. So it goes from 201 down to 300 for the IDs. But everything else there is okie dokie and very good. Next thing I need to do to finish up all of my input is to input my sales items. And there are all the sales items and specifically sales items. And this is item ID, sales order, quantity, discount, taxable, sales rate, and then the primary key, which is auto-generated. There, discount, taxable, sales items. And there are finish up all of my input is one. This is okay, and see sales order and delete that and select everything from sales order. Special note here, all the sale everything and delete that and select everything from sales order. Okay, and whenever we put through those sales orders, we'll be able to see all of them here. Just a special note here, all of my IDs start at 201 whenever this is created. I accidentally hit this twice, so it goes from 201 down to 300 for the IDs, but everything else there is okie dokie and very good. Next thing I need to do to finish up all of my input is to input my sales items. And there are all the sales items, and specifically sales items, and this is item ID, sales order, quantity, discount, taxable, sales rate, and then the primary key, which is auto-generated. There's all of those. And this is the reference to the sales orders. As you can see, they're all in the 200s. And go down to the bottom and throw a semicolon, and then execute that. 200 rows were affected, so that's good stuff. And sales items is what we just changed here. So let's just copy that, get rid of this, and then go select everything from sales item just to verify that it went through. And it did, and everything looks good. And there we go. Now we have all of our data inside of our database, and now we can go start working with it. Okay, so we're going to be through ways to define additional database. Everything looks good. So get rid of this and then go I'm doing it. Well, I'd so total purchase and experience game. All right, and run that actual prints just is the item with a sticker in a way that is that ability to see items. Another way to that up. So let's talk about altering tables of conditional operators, and that is all right here. Again, just make sure that I have a semicolon here at the very end. And execute. Delete that. And so we put through those symbol IDs, and there are effects. So that's good. See that? There we go. We wanted to show all sales with a discount greater, and you can see the different discounts right here. So lots of discounts were handed out. We're also going to have what are called logical operators, which are going to allow us to combine conditions, and those are going to be ands, or not. And let's go and let's see what one of those looks like. So let's say we wanted to find order dates for all orders in December of 2018. How would we do that? Well, I'm going to say specifically that I'm interested in the time the order was taken. So I'm going to say time order taken and from sales orders. And then I'm going to say where time order taken, just throw this in here like that, is greater than, and then I'll define my date, which is going to be 2018 12-01, and I'll say time order taken again, less than, and then we'll go and do the same thing with our date, and we can throw this on the next line, and throw this here, and then change this to 31 instead, and then we can run it, and you'll see that there were 2 actual orders taken. You'd also be able to list out any other additional information. So inside of sales order, we could say, for example, customer ID. So if we want to see what the customer was that did that, we just tack that in there with a comma in between them, run it, and there you can see the customer ID that matches up with it. You're also going to be able to do the same type of thing by using between. So you can say time order taken, and then inside of here, go between, and then get rid of that space, this guy right here, and get rid of this, bring that over here, and then throw that up there, and then run it again, and you're going to see you get the same results. So 2 different ways to get to the same information. Order by is going to be another command we can use to determine the order of the information that's being output. So we could go do our discount again. Here it is. So we can say that we want to get everything, so that's going to be star, from sales item, where our discount is greater than 0.15, and then we could say order by and discount. And if we execute that, you're now going to see that the discounts start off low and grow as they go up. So that's how order by can be used. You're also going to be able to, let's say we want to go from high to low. We just put descending inside of here, and now we can change that up. We're also, let's say we wanted to get just the top 5 discounts. At the very end of this, we could say that we just want the first 5 just by putting a limit inside of there 5, and there those are. And then we could get the next 5 by just putting a comma and putting a 10 after that, and then we would get the next grouping. Okay, so more stuff we can get. We're also going to be able to come in here and combine data. So let's say we wanted to come in and get the first name as well as phone and state for everybody that lives in the state of Texas. So we could go select and concat and follow that up with our first name, and then put a space inside of here, another comma, and last name, and concat will combine those 2, or concatenate, so that's what the word stands for. And another thing, we can do an alias. Let's say we want to list this as name in our output. We just put as name, and that's going to show up in the table whenever we go and execute this. We could then get phone and state, and then from customer, where state is going to be equal to Texas. There it is. So that could be useful for a salesperson or something. And you can see right here, there is the name alias that I referenced, and then you can see the phone number and the state that is shown there also. So a whole bunch of those guys. We'd also be able to perform all sorts of different calculations inside of here using these queries. So let's say we want to go select and get the total value of all business shoes in our inventory, for example. We could go select and product ID, and then go sum and price, and we could change this. So we can use alias again as value from, use the item table, where the product ID is equal to 1, and you can see we got our total right there. Distinct is going to be another command we can use to help eliminate duplication, is equal to 1. And you can see we got our total right there. Distinct is going to be another command we can use to help eliminate duplication inside of our results. So let's say we wanted to get a list of states we have customers in. We could say select and then distinct state from our customer table. And let's say we want to order them alphabetically, order by state, run it, and there we go. Got the 5 states where we have customers. We could also come in and say we wanted to get all the states where we have customers, not including California. And to do that, we'll say, we would do all of our conditions inside of where clauses. So we'll say state not equal to California. Run it, and then we just get all of our states excluding California. The in phrase can also be used to test if a value is inside of a list. So we have select distinct state from customer, and then we'll say where state in, and we'll say that we just want those states that match with either California or New Jersey. So we can say, do we have customers in California or New Jersey? And it comes back, and you can see that yes, indeed, we have both. All right, so there's a couple different ways we can use queries, and I'm going to cover many more, but now I want to talk about getting data from multiple tables. Now we're going to be able to get results from multiple tables with either inner joins, outer joins, or unions, and I'm going to show you examples of all of those. And the most common join is the inner join. That's what you're going to use most of the time. And with it, you're going to join data from 2 tables in the from clause with the join keyword. And then again, we're going to have an on keyword, which is going to be used to define the join conditions. So let's say we wanted to do something like get all items ordered ever, and then sort them by ID while listing their price. So we could say select item and ID and price from, and we'll say item, and then we want to do an inner join so that we join the items table with our sales item table, and our condition is going to be defined after on, and the condition is going to be item ID is equal to our sales item, which is item ID, okay? And you can see how we're able to use primary keys and foreign keys to join data. And then we'll say we want to order them by the item ID. Run it, and there you can see. And there is all of our pieces of information for our item ID as well as the price for that. And that is just the beginning of the usefulness of joins. We're also going to be able to use the join condition to find IDs that are equal in the tables item and sales item. And in this situation where we join tables while checking for equality between a common column, this is called an equal join. We're also going to be able to define multiple different join conditions with logical operators. So we have item ID and price from our item table and our sales table. Let's say we want to come in here and keep this part right here where we're joining using the foreign key and the primary key. But we also want to say, and the price is greater than $120, for example. Run it, and there you can see that. But now we're going to get into some funky stuff because what I want to do here is actually show you how to join three tables. So let's say we want to get the orders quantity and the total sale. So So we could say select sales order, and we'll get our ID, follow that up with sales item quantity, and the individual item price. And then we want to say sales item quantity times the item price. And we'll go and create an alias, which is going to be total. And we'll say that we want to get that from the sales order table, which we will join to our sales item table. And the condition is going to be that our sales item sales order ID is equal to, whoops, accidentally put a space inside of there, is going to be equal to our sales order ID. And then we can do another join. And we'll say join item on item ID equal to sales item ID. And then let's order this by our sales order ID. So now we're getting into some really good stuff. And if we run it, you're going to see here, quantity 1, the price of the individual item was $139.26, and the total, of course, is the same. And then as we add in additional information here, we have quantity 2. You can see the total sale and how they match up with the different order IDs. All right, but as we go, we're going to get into even better stuff. But one thing that I left off are the arithmetic operators that we have. So, of course, we have plus, minus, subtraction, and integer division, as well as regular division. And modulus is just, it provides the remainder of a division. And we'll see more on that, and we'll do more with them as well. Another thing that's going to be available to you, but it's kind of frowned upon, and you're not supposed to do it, but you can do it, so I'm going to show you, is actually defining the on condition with where instead of on. So you could actually come in and go select item and price from our item table as well as our sales items table. And then you could say where item ID is equal to sales item dot item ID and price is greater than 120 and order by item ID and run it. And you can see you get those same types of numbers that we saw before. So just another option. And that's just the beginning of inner joins. Much more is coming, but now I want to talk about outer joins. And you can see, and then you could say item and price, do more with them as well. Integer division and additional information. Here we have quantity 2. You can see the total item ID. Get those same types of numbers that we saw before. So just another option being joined, even if no matches are found. So there's going to actually be 2 of them. A left outer join is going to return all rows from the table being joined on the left, while a right outer join is going to return all rows from the table on the right. Now it's common practice to avoid right outer joins, so I'm just going to use left in this situation. So here, let me just give you an example. So we can say select, and let's say what name and supplier and price from product left join with item. So here's the product table and the item table, and we're using a left join here on item. Define our condition for how this is going to match up. So product ID equal to product ID, and then order by name. Whoops, name. There it is. And run it, and there you can see all of our results. Once again, there is our name, and there's the supplier, and there is the price for the joining of the product and the item tables. All right, so quick example of an outer join. We'll do some more later on, but now I want to talk about cross joins. Now, a cross join is going to include data from each row in both of our tables. So what I want to do is grab information from the item as well as the sales item table, and this is going to produce a whole ton of different results. And because there is no join conditions, whenever you're using a cross join, you're really rarely going to see them, but I just want to cover it just so that I can. So what you do here is you say select sales order ID and quantity and product ID from item table, and then you type in cross join. That's where the name comes from. And sales item, and then see, there's no conditions here. You get it all. Order by and sales order ID. And if we execute it, there you can see there's every single thing. All right, so that's a cross join. And why don't we talk about unions? Basically, a union is going to combine the results of 2 or more select statements in one result. Now, one thing that's important to understand with a union is each result must return the same number of columns and data in each column, and on top of that, the data in each column must have the same data type. So let's say we wanted, just as an example, to send birthday cards to all our customers as well as our salespeople for the month of December. How could we do that? Well, we're going to say select and first name and last name and street and city and zip. See if I can spell zip right. There we go. And birth date. And we're going to do this from the customer table where month is how you get the month only out of, let's see if we have, this is customer, right? You see here is a birth date, and there's a date. That's the date data type. If you wanted to just get the month out of it, you could also use this with timestamps. You could just type in this, and then birth date equal to 12. And see here is where union comes in. It's going to allow you to combine data from two different selects. So this is almost exactly the same. So let's just copy this and paste this in here. All of this is exactly the same, except we're going to change this to salesperson, and everything else is the same. And then we'll end this off with order by birth date and run it. And there you can see all of the customers as well as salespeople who have birth dates in December and when those birth dates occur. All right, and all that other information. So neat stuff. So that's how unions work. They allow you to basically unite to select queries. On a side note, probably also should talk a little bit more about null. You're going to be able to go and check for null. And null is used whenever a value is not known. So what we'll be able to do here is say something like select product ID and price from the item table where price is equal to null, and nothing comes back. That's the reason why, is because all of my products have prices assigned to them. You're also, however, going to be able to come in here and just change this to is, and that's going to give you the same result, but you can also come in and go is not null, and that's going to give you some returns here because now everything has prices. All right, so just a little trick for using null and checking for null and so forth and so on. And now I want to talk about like and regular expressions. Okay, so like is going to be used to search for simple string matches. So let's just give you some examples. Let's say I wanted to find any customers whose name begins with an M. So I can say first name and last name from customer, and then where first name like, and then follow that up with M, and then I can put a % sign inside of there, and that is going to give me my matches. And you can see there is a good number of them. Okay, another thing, well, basically what the % sign is going to match for this guy is it's going to match for 0 or more characters. You're also going to have an underscore, which is going to match any single character. So let's go and do something similar for this. Let's say I wanted to find any first names that begin with the letter A. I can come in here and say A like that. And then let's say I want to find if there is an Ashley. So that would be A-S-H-L-E-Y. I don't know if there's an Ashley, but we'll find out. Yes, there is. So you can see you do an underscore for each individual character. And that's basically what you can do with like. You could, however, also, let's say we want to return all customers whose first name begins with D or whose last name ends with an N. Well, we can do that. So we'll say first name, like, and we'll throw a D inside of here, and %, and we're going to say or, and then last name, like, and then we'll go % sign, N. And I think I did, oops, I have to put that there. Okay, so we got those, and let's run it, and you can see there we go, all those matches. All right, so that's basically what like's going to give you. It's going to give you the ability to match for 0 or more characters or match for any single characters. Then we get to regular expressions. They are a lot more complicated. And I'm not going to be able to cover everything, but I have an entire tutorial just on regular expressions, but I am going to give you some examples, and I'm also going to give you an overview of what is available to you with regular expressions. All right, so here are some regular expression patterns. A period is going to be able to be used for any single character, just like with like and underscores any single character, well, period's the same. Star is going to match for 0 or more of what comes before it. Plus is going to be 1 or more. The caret symbol is going to represent the beginning of a string match that you're looking for, while a $ sign is going to represent the end of a string. Anytime you want to match, like for example, the characters A and B, just put them inside of brackets. And if you want to match anything except A and B, put the caret symbol inside of there. This guy's going to match all uppercase letters. This is going to match all lowercase and all numbers. If you put a caret in there, it'll match anything except those things. And if you use the curly brackets and N after something, it's going to match N instances of whatever it is. So let's say you wanted to look for mall and you wanted to match for 2 L's. Well, you would have L, and then you'd have inside of curly brackets 2. So it's going to match those 2 L's. You can also match between an M or N instances. So it would match for mall or whatever else, pal, I don't know. And you can also use this or symbol expression to come in here and match for one thing or another thing. So here's some examples of using regular expressions. Let's say we wanted to match for a first name that starts with the letters M and A. We could just go in first name again. We're going to use the customer, and then inside of here, instead of like, we're going to put this here, and then we will say like that, and then like this, and then it'll give us all our matches for names that start with MA. We're also going to be able to get, let's say we wanted to get the last 2 letters be easy. Well, we would put a $ sign inside of there, and nothing comes back. Don't know why, but that's how you would match for that. Oh, I know why, because let's change this to last name. Now it'll work, and there we see all the Martinez's that pop up. We could also come in and match last names that contain just certain letters. So let's say we wanted to look for EZs or put an or sign in there, SON, run that, and you can see all those show up as well. And we could also come in and say like a $ sign inside of there, and you're gonna get the same type of results, but just want to run that. So you can combine all those different little tools and patterns. And you also could come in here and say that you wanted to match for last names that contain letters W through Z, for example. Put those in brackets, and there you go. And you could do last names that have at least 2 L's inside of them. So go like this and like that. And whoops, only put that there. Okay, and run it, and you'll see Williams comes up. So just a whole bunch of different things. Like I said, in the description underneath, I will put a link to my regular expression tutorial to give you an overview. It'll show you some ways to summarize your results. Okay, so group by is going to define how the results are going to be grouped. And we have another function called count, which is going to return the total number of records that match. So what we want to do here is use group by to return a single row for each unique value. And like what we're going to do here is say, or look up how many customers have birthdays in certain months. So we'll go select month. That's just going to say what is going to be displayed at the top of the table. And let's say we want to count all the individual amounts. That's going to allow us to do that. And we'll name this amount. Then what we want to do is define, we want to take this from our customer table, and we want to group, whoops, go down here, group by month. So we'll just have everything grouped into all the individual months and order by month. Okay, so this is going to show us this. And you can see right here that in the month of January, we have 1 customer, and so forth and so on for all of the other months of the year. All right, so that's one way to use group by. Later on in the tutorial, we're going to get even more complicated stuff. But let's say we wanted to find those months that had at least 2 or more customers with a birthday in them. Well, to do that, we have another command called having, and you have to put having after group by. So we could say something like having amount greater than 1, and run it. And now you can see it's only giving you the results where we have 2 or more people having birthdays in individual months. So pretty neat stuff. And let's go and do another thing. It's kind of interesting to finish up working with group by. Let's say we wanted to get the total purchases from each company. How would we do that? We're going to go select and customer ID and the company involved, and we want to count them. So like that, and we'll call this as purchases. And we're going to get this from our sales order, and we're going to join this to our customer table, and we're going to do that using our condition here, where the customer ID is equal to customer ID, and then we will group by customer ID, and run it. And you can see all the individual companies and how many purchases each of those companies made. So pretty neat stuff. It's just so easy to work with data using SQL if you know how to use it properly. And now what I want to do is jump over and show you some of the other aggregate built-in functions. All right, so here's a whole bunch of them, and I've been using them in my statements, so I think you'll be able to pretty easily figure out how to use them. And as the tutorial continues, I'm going to use a couple of these. So you can see we can get the absolute number. There's all kinds of trig functions. You can average, and by averaging, we would average the column name. Ceiling is going to round up. Degrees is going to convert from radians to degrees. You can see there's exponent. Floor is going to round down. There's 2 different log functions. The mod stands for modulus, which gets you the remainder of a division. Pi is built into MySQL. We can go and find the power of different values. We're going to be able to convert from degrees to radians. You're going to be able to generate random values from 0.0 to 1.0, and then you can go and add or multiply those values to get all kinds of different random values. You're going to be able to round. Basically, it's going to round down. If it's less than, like for example, 4.5 is going to turn into 4, and if it's 4.6, it's going to turn into 5. That's what the round function does. We have square root, we have standard deviation, and a whole bunch of other different things, but those are the general functions that I personally have not used in this tutorial or don't plan to use. So there you go, a rough overview of those. And now what I want to do is talk about some other different aggregate functions and give you some examples on how they can be used. So just to start off here simple, let's say that I would want to sum the prices of all my items that I have. I can just go select and sum and price and from item, and that's going to run, and it's going to give me my total inventory value of $7,231.58. Okay, so let's go and get even more things. So let's say I'm going to use a whole bunch of these aggregate functions, and an aggregate function is just a function that returns a single value from multiple parameters, and it doesn't have to be multiple parameters, just do one. All right, so we could say as item, and I'm counting all of my items that I have. I'm just going to show you a whole bunch of them. I'm going to sum the price as value, and what else can we do? I'm going to show you rounds, and what I'm going to do is go and get the average price divided by 2 decimal places, or I want to use 2 decimal places in my result, and then I'm going to say that's called average, and let's go and get to the minimum price as well, and we'll call that min. Do a couple more. Let's also get our max price, and this is for all my different items that I have in my items database, and let's just do from item. Okay, so that gives me a rundown of my inventory. You can see right here, I have 50 items, total value, the average cost, the minimum cost, and the maximum cost. All right, so that's a rundown of aggregate functions through examples as well as a list, and now I want to talk about working with views. All right, so views are select statements that results are going to be stored in your database. So what I want to do here to give you kind of a real world type of example is I'm going to create a view that contains our main purchase order information. So what I'm going to do is I'm going to say create view purchase order overview is what I'm calling this view. Purchase order overview as, and then afterwards I'm going to put in a select with a whole bunch of different joins to combine a whole bunch of data from a whole bunch of tables. So what I'm going to do is I'm going to say that I want to get my purchase order number from my sales order table. So purchase order number. This is going to be like a real use is I'm going to add functions through examples as well. The items, total value, the average cost, the minimum cost, and the max from item. Okay, so that gives me a rundown of my inventory that I have in my items database. And let's just do from item. Okay, so that gives me a rundown of my inventory. And you can see right here, I have 50 items, total value, the average cost, the minimum cost, and the maximum cost. All right, so that's a rundown of aggregate functions through examples as well as a list. And now I want to talk about working with views. All right, so views are select statements that results are going to be stored in your database. So what I want to do here to give you kind of a real world type of example is I'm going to create a view that contains our main purchase order information. So what I'm going to do is I'm going to say create view purchase order overview is what I'm calling this view. Purchase order overview as, and then afterwards I'm going to put in a select with a whole bunch of different joins to combine a whole bunch of data from a whole bunch of tables. So what I'm going to do is I'm going to say that I want to get my purchase order number from my sales order table. So purchase order number. This is going to be like a real useful thing. I'm also going to get whatever the company is that made that purchase. I'm going to say that I want to get the quantity that they bought. So sales item and quantity. I'm going to get the product supplier. So that's going to be like Nike or whatever. And I'm also going to get the individual product name. So product followed with name. I'm going to get the item's price, and I am going to go and get the quantity and multiply that times the price to get the total. So I'll go sales item underscore item, and that's going to be quantity, and multiply that times the item's individual price, and I'm going to give that an alias of total. All right, so I think that's pretty, you know what, let's put even more in here. I'm also going to go and put the salesperson that made the sale into this. So concatenate, and I'm going to put salesperson and their first name, and salesperson and their last name. And let's give this the alias of salesperson. Okay, now to get that, I'm going to join some tables. So I'm going to say from sales order table, I'm going to join sales item. So those 2 tables go together. And how are they going to go together? They're going to go together by comparing the foreign and the primary keys. So I'm going to say on sales item, go like that, and sales order ID being equal to the sales order ID. And then I'm going to join even more. So I'm going to say join item, and how am I going to join it? Well, I have to give it a condition. Again, it's going to be the primaries to the regular foreign keys. So I'll say item ID is equal to the sales item item ID, and let's join some more. So it's just going to keep going. I just want to give you some real world examples. From now on, the rest of the tutorial is going to be pretty much real world stuff. I'm also going to need to join our customer. So join customer to all these tables. And how I'm going to do that is going to be on sales. So anytime you want to join two different tables, what you're going to need to do is find those foreign keys and primary keys that match up. So this is going to be sales order. Let's get out of there. There we are. Order dot customer ID equal to customer ID. And I'm also joining the product table. So this is a really complicated guy here. I'm also going to go product. And how am I going to match those up? Guess how. I am going to go product ID equal to item dot product ID. And then also I have to join the salesperson. So I'm going to say join. And this is going to be salesperson. Geez, I'm running out of screen here. There's salesperson. And on, this is going to be salesperson dot ID equal to sales order, salesperson underscore ID. And then as a final thing, I'll say order by purchase order number. All right, so that is a long query that's going to give us some crazy stuff, and it's going to store everything in a view. So let's run it. As long as I didn't type anything wrong, it should work. And it looks like it did. So let's come in here and just refresh all. And now you're going to see over in views that there is a view, and there it is right there. You're also going to be able to see our different results here if we go and look at it. And how we're going to do that is let's just select all of this stuff, and to see our purchase order overview, which is going to be stored in the database, and it's going to update also as other parts of the database update on its own. So I'm going to say select everything from the purchase order overview like that and run it. And whenever you do, it's going to give you this view with all of that information that we requested. So pretty neat stuff and very, very useful. And that's how we go and create views and how they work. All right, from the purchase, and it's going to do that is let's just select all of this stuff, and to see our purchase order overview, which is going to be stored in the database, and we're going to go over in views that there is a view, and there it is right there. You're also going to be able to see our different results here if we go and look at it, and how we're going to see over in views that there store everything in a view. So let's run it. As long as I didn't type anything wrong, it should work. And it looks like it did. So let's come in here and just refresh all. And now you're going to see over in views that there is a view, and there it is right there. You're also going to be able to see our different results here if we go and look at it. And how we're going to do that is let's just select all of this stuff, and to see our purchase order overview, which is going to be stored in the database, and it's going to update also as other parts of the database update on its own. So I'm going to say select everything from the purchase order overview like that and run it. And whenever you do, it's going to give you this view with all of that information that we requested. So pretty neat stuff and very, very useful. And that's how we go and create views and how they work. All right. Now you're going to be able to drop this view if you decide you don't want it anymore, just by coming in and saying drop view and then follow that up with whatever the view is you want to drop. And I want to do that. And it's also important to know that, and as a side benefit to a view, is that they are going to allow you to hide or change data in other tables while keeping the view the same. And this is beneficial in hiding data from users who shouldn't have access to it directly. And one thing, however, to be aware of is if you want a view to be updatable, it can't include the terms distinct union, it can't have any aggregate functions in it, nor can it have group by or having. So knowing that, I need to change my view that I had previously, and this would be the new format of it. Basically, what I had to change here about this is I had to remove the aggregate functions because I didn't have any of the other issues. So that means I have to get rid of concat and all that stuff. Let's just come in here and go sales, fname. Well, I could do a concat in another way, but I'm just going to do it this way right now. So this is basically the way the view is going to look that is going to allow it to be updated. Like I said, I just remove the total aggregate. You can pause your video if you want to type that in, or like I said, all this is available for download. Get rid of this and to new one. So we can come in here and run that. Or actually, you know what? I have to go and drop the other one first. So let's do that. Okay, so let's get rid of this and to purchase order overview. So let's go drop view, purchase order overview like that, run that, get rid of it, and then go in and create the new one. Throw that inside of there, now run it, and now we have the new one. And now if we wanted to get that aggregate function like the totals and things like that, we still can. All we need to do is come in and do something like select everything, and then we can add to it. So then we'll also say quantity times price as total from purchase order overview. And there we go. Now we got our same results. Whoops, you don't have to save that and run it. And you're going to see we get the same results that we were expecting. All right, so pretty neat stuff. And there's an example of how views work and some of the issues with them and how to solve them. And now what I'm going to do is talk about stored programs. Now you're going to be able to write programs that are similar to traditional programming languages. And there are different types of stored programs. There are stored procedures, and there are stored functions, and there are triggers and events, and I'm going to show you all these. Basically, a stored procedure can be executed by an application that has access to your database, so PHP can access it, basically anything can. And a stored function is going to be executed using your SQL queries, like you keep seeing. Triggers are going to execute when either insert, update, or delete commands are executed, and events are going to execute at scheduled times. I'm going to show you examples of all of them. So what I'm going to talk about first is how to create a stored procedure that's going to let you get a list of customer company names. So how you create it is, first off, you need to define the database you're using. So I'm going to say use sales DB. So there's the database we're using. And then what you need to do is say drop a procedure if exists. If I already created a procedure with a name, as you saw previously, it's going to give me an error unless I say that I want to delete the previous and update it with the new stuff. So that's what this is going to do. So I'm going to call this get customers. That's the name of my stored procedure. So it's going to, if I change it, it's going to just say go and overwrite it. Then what you need to do is switch the delimiter like this. and I'm going to switch the common delimiter is with a semicolon. I'm going to switch it, as you see, every statement ends with a semicolon. I'm going to change the delimiter to 2 forward slashes, and this is going to allow me to use semicolons inside of my stored procedure. And then whenever I'm done, I'll switch it back. So now to actually create the stored procedure, you go create procedure, and you already saw the name of it, get customers, and you can pass values inside of here. So I'll say get customers. I'm not going to receive anything though to start off. And then begin is going to assign the beginning of where the procedure code is going to lie, and then you're going to do whatever you want to do. So I'm going to say select customer company from customer. Just do something pretty simple here, and that with a semicolon, and then we're going to say end and 2 forward slashes, and then at this point I can say that I want to switch the delimiter back to semicolons, and then to call for this stored procedure to execute, I say call get customer. You can call this outside here, but I'm just calling it here so you can see it execute, and I'll run it. Whoops, get customers. There we are. I have that the same. All right, good. Get customers, and you can see it gave us a list of all of our customers. All right, so neat stuff, and we're going to do way more complicated ones after this. Let's say that, for example, I'd like to create a procedure that returns inventory value based on supplier. A lot of this stuff's going to stay the same. Sales DB is going to be the same. Delimiter is going to be the same. Down here, I'm going to say get supplier value. So I'm going to say get, do it here too. Get supplier value. So supplier underscore value, and create that procedure. So get supplier value. And then this guy's actually going to receive a argument, which is going to be the supplier's name. So call it, and you have to define what the data type is going to be. So there's that. And then I want to declare a couple things inside of here. So I'm going to say I'm going to declare some variables that are only going to be used in this stored procedure, and they're going to hold results of a query. So I'm going to say supplier name, variable number of characters, 30 in length. You have to define the variable name as well as the data type for it, and you'll see how the data is going to be stored inside of it. I'm going to go and get price sum, which is going to be a decimal. That's going to be 8 potential total numbers with 2 decimal places. And then I go and issue my query, get the results, and store them. So select and product supplier, and I'm going to sum, and sum is going to go in price sum. So you just say into supplier name, this is where the results go, comma, and then price sum is where the other one goes. So throw that right there. Then I just continue the way I would always do it. I'm going to say that I want to get information from the product table and the item table, and then the condition, which is going to be that the supplier is going to be equal to the supplier that they passed into the stored procedure up here. See, this guy right there. And there it is. And then after that, I can output this in supplier. I can say price sum, and then if I want to give it a custom title as output, for example. And that's everything I need to do. Oh, actually, no, I'm going to go get supplier value. So I'll get all the values for whatever I throw inside here, and I'm going to say that I want the total value of inventory from Nike. So there's everything. And if I run it, you're going to see Nike inventory comes back, and it has a total value of $21,694. So that is out of money in Nike tennis shoes, and now inventory comes back, and I'm going to say that I want the total value of inventory from Nike. So there's everything. And if I run it, you're going to see Nike inventory comes back, and it has a total value of $21,694. So that is out of money in Nike tennis shoes, and now I'm going to show you some more stored procedures. Okay, so now I'm going to show you how to accept multiple values, and you already saw this in parameter right here, and what it does is it just designates a parameter expected to be passed to a procedure, but what I didn't tell you, a procedure that's going to get customer birthdays. So let's just come in here, and let's call, and then we're going to use an out parameter, and what it's going to do is pass values back to the code that called for the call it. We'll say birthday month, also an integer number of characters, and let's say it's 20. Out again, which is going to be the last name, again, variable number of characters, which is also 20. All right, so now we defined all those. Let's go and get all that information. So inside of begin and ends, we're going to say select of characters, also, and we'll say birth date, and then we'll do day, and again, birth date, first name, last name, and phone number. And we're going to be taking this from the customer database, of course, so from customer, and then we'll say where month, birth date is equal to the month that they passed in. So they'll be able to pass in a month, and it'll automatically send you back all the customers who have a birth date in that month. Everything else here is the same, and except we're going to call our new get customer birthday, pass inside of it the month of what would be September, and then what you have to do is put at and all of your different amounts that you have up here. So you have birthday month, this is where it's going to be coming from, and again at and birthday day, at first is right there, and if we come in and execute it, oops, and at phone number. And close that off, and I think everything is right there. And if we come in and execute it, oops, I have an error down here. Let's go and correct that somewhere. I put BIR day. Oh, right here, get customer birthday. So everything else is fine, and run it again, and you'll see all the different customer birthdays that we have, which are right there. Another thing I don't know if I even showed you is if we go and refresh all, under these stored procedures, you're going to see all of those procedures that we have created so far all stored inside of the database, as well as the view that we had before. So pretty cool stuff. Now what I want to do is go and demonstrate if and else if and else. All right, so what we're going to do here is we are going to check for our monthly orders and to see if we are performing well or not. So I'm going to keep everything basically the same, except I'm going to change a couple different words here, a couple different names, of course. So I'm going to call this check month orders, and if it's at a certain number, it's going to say it's good, and if it's not, it's going to say it's bad. So let's go to this and change this name of the procedure here. We're going to receive a month, which is an integer again, and then down inside again, we're going to declare a variable, and it is going to be total orders, which is an integer, and then we'll go select count and per have, so that's where that's going to go, the value that is returned whenever we call count on purchase orders numbers, and then we'll say from sales order where, and we'll say month, time, order, taken, equal to the month that the user passed in. Now what we're going to do is we'll use if else and else if statements to check to basically provide output. So we'll say if total orders is greater than 5, then we want to output a message. So we'll say select concat total orders And then we can say orders, doing good. We'll say that if it's 5 orders or more, we're doing good. And then we can change our output for this to just output as the top of the table that's output. Then we can say else if total orders is less than 5, then, and again, we're going to use something very similar to this, so I might as well just copy it, paste that inside of there, and we can say doing bad. And then finally, as a default, if neither of those is true, well, we know we have exactly 5 orders, so we can say something like on target. And then after you're done with the if block, you have to say end if and put a semicolon. And now to test this, we can come in and let's just go check month orders and call get month orders. We don't need all this stuff, so let's just get rid of it. And then the month that we want to check, let's just check September again, and let's run it. And we see that we have 9 orders in this month of September, so we're doing good. All right, so there is another stored procedure, and of course it's going to be stored over here, and there it is. And now let's go and do another one where we're basically going to do everything we did here, except we're going to use case. All right, so basically everything is exactly the same, except we're going to use case in this situation. Basically, case is going to execute everything we did here. The if block, you have to total orders is less than 5, then, and again, we're going to use something very similar to this, so I might as well just copy it, paste that inside of there, and we can say doing bad. And then finally, as a default, if neither of those is true, well, we know we have exactly 5 orders, so we can say something like on target. And then after you're done with the if block, you have to say end if and put a semicolon. And now to test this, we can come in and let's just go check month orders and call get month orders. We don't need all this stuff, so let's just get rid of it. And then the month that we want to check, let's just check September again, and let's run it. And we see that we have 9 orders in this month of September, so we're doing good. All right, so there is another stored procedure, and of course it's going to be stored over here, and there it is. And now let's go and do another one where we're basically going to do everything we did here, except we're going to use case. All right, so basically everything is exactly the same, except we're going to use case in this situation. Basically, case is going to execute different code depending on an exact value. All right, so basically everything is exactly the same, except we're going to use case in this situation. We're basically going. All right, so there is another stored procedure, and of course it's going to be stored over here, and there it is. And now let's go and do another one where we're basically going to do everything we did here, except we're going to use case. All right, so basically everything is exactly the same, except we're going to use case in this situation. Basically, case is going to execute different code depending on an exact value for total orders or a range of values. So we're going to say case, and then follow that up with when total orders is less than 1, then, if that's true, we will execute, well, I thought I had it saved, but I don't. So we'll say select, concat, and total orders. And again, we're going to print out exactly the same thing. So it's just another way of doing the same thing. We'll say terrible in this situation. And then we'll put that as output like we did before. And now let's go and copy this because we're going to be doing the same type of thing. Then we can say when total orders is, we can say greater than 1, less than 5. So you can stack them oddly like that, shortcut. And in this situation, we can say get better. Again, do another when, and we'll say total orders equal to 5, then, and do another one inside of here, and we'll say that this is on target. And then finally, as a default, we'll say else, and paste in another